All right, here we're going to be talking about simultaneous equations, and after that also the application of simultaneous equations using the discriminant to find out how many times a straight line will intersect with a parabola. Okay, so let's have a look at the first one. Calculate the coordinates of the points of intersection. So coordinates are always going to imply that you need an x and a y value. Okay, so let's do that first one. We have y equals x squared minus 3x minus 4 and y minus x equals 1. All right, I'm going to rearrange the second equation. Let's call that equation 1 and rewrite that one as y equals x plus 1, and that's equation 2. And we're going to substitute 1 into 2. You should have worked with simultaneous equations like this last year. X squared minus 3x minus 4 is equal to x plus 1. Let's rearrange that, and what we're going to get is x squared minus 4x minus 5 equals 0, and that should automatically make you want to factorize and solve using your null factor law. So by the null factor law, and we always write that x is equal to 5 or x is negative 1. Now you're not finished, because what they've asked for is for the coordinates of the points of intersection. So that means you need to substitute x equals 5 back into one of your equations, and also x equals negative 1 into both of your equations. Okay, so we're going to substitute x equals 5 into, and I would probably pick the one that I'm least likely to make an error with, so 2 is a whole lot easier. So y is going to be 5 plus 1, which is 6. My first coordinates, my first point, are 5 and 6. And then I'm going to substitute x equals negative 1 into 2, so that I have y is negative 1 plus 1, and that gives me 0. My other point is going to be negative 1 and 0. Okay, so therefore the points of intersection are 5, 6 and negative 1, 0. All right, let's have a look at the next one. Determine the number of points of intersection. Now that the number of points, they don't want the actual points, they want to know how many, and immediately that should be making you think that's got something to do with the discriminant. Okay, so let's have a look here. We have y is 2x squared plus 5x plus 6, and we have y is 2x take 5, and I'm going to make this equation 1, this equation 2, and we're going to solve them simultaneously. We're going to say substitute 1 into 2, and we have 2x squared plus 5x plus 6 is 2x minus 5. 2x squared plus 3x plus 11 equals 0. Now we've got this in our form ax squared plus bx plus c equals 0. We're not trying to solve for x, we just want to know how many points of intersection there are, and for that we're going to use our discriminant. Okay, so we have that delta is b squared minus 4ac. So we have our b is 3, so 3 squared minus 4 times 2 times 11, and that gives me 9 minus 88, and that gives me negative 79. I don't really care what the number is as such. I'm interested in the fact that this is a negative number. So that would mean that I would have a square root of a negative number inside of my quadratic formula. And that tells me that there are no real solutions or no points of intersection. That line misses the parabola completely. So we need to say delta is negative, therefore there are no points of intersection.